All right, welcome to our last section, 9.7. And what we're going to do here is we are going to learn and understand how that we take the general form ax squared plus bx plus c of our quadratic equation and convert it into standard form or vertex form. Y equals a times the binomial x minus h, all that squared plus k. Now, the one technique that we're going to use is completing the squared. Now, this is going to be slightly different than when we were solving. All right. Now, the one thing that happens here is that you cannot change the y. It has to stay there. So we don't want to alter it. So what we're going to do is we're going to keep, like I said, y by itself. And now what we're going to do is when we can't add something to both sides, what we're going to do is we're going to add and subtract something to the same side. So the first thing you want to imagine doing is putting parentheses around your x squared and your 8x, because the plus 1 doesn't help. Next, we're going to put in plus blank on the inside. We're going to add on the inside, but we're going to subtract on the outside. So once you get used to this, you can go from this step to this step right away. Now, we still complete the square. We fill in our blanks with the same technique. It's just that we don't want to put a plus blank over here by the y because we're not supposed to alter the y. So plus blank again on the inside, minus blank on the outside. So we go to this middle term of a positive 8x, and we're going to take half of that, which is going to be positive 4 squared is 16. So now on the inside, this will factor to two binomials, x plus 4, which becomes x plus 4 squared, and 1 minus 16 is minus 15, and all of a sudden, bada bing, bada boom, hey, there you go. You've got the vertex form. Now, if we have a leading coefficient other than a 1, you can still complete the square, but I would double check to make sure that this a can divide evenly into the b. If that's not going to work, we have another technique that we'll look at here in just a second. All right, so again, rule of thumb, group the x terms together. Put a plus blank on the inside and a minus blank on the outside. Now here we're going to slow down. This is where it gets a little tricky. So to complete the square, we're supposed to have a 1 in front of the x squared. And again, when we looked at solving, we were dividing the 3 over to the other side, but we can't change the y. So what we're going to do is we're going to take the 3 and factor it out of this trinomial. But wait, there's no value here. Don't panic. I show you how we deal with that. We factor out the 3 in front. Again, that gives us a 1 in front of our x squared, which is great. But the one thing you have to remember is that this blank has to be multiplied by 3. This was supposed to be a multiple of 3 because we divided 3 out. So whatever we put in here, you got to multiply by 3. So the smart thing to do is that if you ever take out a GCF, you go over to this blank outside the parentheses and put 3 times parentheses. That way this blank in the parentheses will get multiplied by 3, and so will this blank over here. So we go through our normal steps. Half of negative 4 is a negative 2 squared, which is 4. Now, this 4 gets multiplied to this 3. That's going to make it minus 12 with a minus 5. That's going to give us a minus 17. And our binomial squared becomes x minus 2 squared. All right, so while we're here, I want to show you a nice trick. Hopefully my calculator doesn't crash like it's been doing lately. So bear with me here. What you can do to make sure that it's right is if you go to y equals, let me clear that out. Just ignore this. This is from a different class. type in the original equation. Okay, 3x squared. Very similar to what we were doing earlier when we made our graphs, so you could see the vertex. So 3x squared minus 12x minus 5. Okay, now I go down here for y sub 2. You type in the question, or the equation that you get. 3 parentheses x minus 2 parentheses squared minus 17. Okay, now because this is vertex form, that's indicating to me that I need to really get to the bottom of my window. So if I go to my window, whoops, I go zoom 6, this only goes down to -10, and you can see that it doesn't show me the bottom. That's what's important here. So I want to probably take my window and change the y-min to a -20. That way I know that 17, that's at -17, it's going to fit on my graph. And hopefully you notice as I've been graphing these, okay, that you notice that the blue graph shows up first and the red graph traced right over the top. Again, show you, oh, I didn't do that because I need to type something in. If I just do the 3, I think it'll work. There's the blue graph, there's the red graph traced right over the top. That tells me that this standard or vertex form matches this. Now, one of the big mistakes that's going to happen if you attempt to complete the square with some value other than 1 in front of your x squared is that we're going to forget to put that 3 there. So it's going to be -5 minus 4, which is a -9. So if I go back to my 17 here, and I delete that, and I change it to a -9, and I graph it, you notice that, hey, wait a minute, my red graph did not trace over the blue. And in fact, it's already telling you what's wrong. My graph in red did not go down far enough, so that's telling me that that -9 here, if I forgot the 3, is wrong. Oh yeah, that's right, we forgot to multiply by 3. Okay? So keep that in mind. The other thing, again, I want to show you real quick. Let me go back and change this to a -17, because sometimes, again, when you are checking these, we might goof up the sign on the inside of our 2 here. Let's say it's a plus, and I graph it. There's the blue, but now notice that the red graph is down far enough, but it's over to the left. Well, if I'm off left and right, that's got to be a mistake on the inside. Okay, we don't want that +2, we want it as a -2. If my mistake is up and down, then I got to change this number, got to make it right. So that's how you can use your calculator to help you solve that. All right. Now, like I say, I completely agree. I don't like completing the square unless that, again, that A divides evenly into the B. But again, however, I don't want to make that mistake of forgetting to put that 3 there. So a great alternative to completing the square, great when there's a 1 in front of the x squared, not so hot here because we have a potential error, is called the vertex formula. The vertex formula should always be used when A doesn't equal a 1. So as we saw in the last example, it's very possible to forget your GCF in that outside blank. Well, notice that in a general form, this A and this A are exactly the same. So the real difficulty here is finding the H and the K. That's our key. All right, so what we're going to do is the following. We are going to have a formula that just finds H and K, and that's it. All right, and that's what we call the vertex formula, and it looks like this. It's actually written as a point. V is our vertex, name of our point. There's your H, there's your K. And that's the only other two values we have to find, since this a is the same as this a. All right, so here in this example, just like we did the quadratic formula, a is 3, b is -6, c you actually don't need because there's no c in this formula. But what we can do with this 3 is go put it into your vertex formula right away. So let's say we're building our answer down here. Next, you take a negative, -6, and then 2 times 3 on the bottom. So here, you're just finding the x coordinate. We'll just kind of leave this on the back burner. Well, a negative is a positive. 6 on the top, 2 times 3 is 6 on the bottom. This all simplifies to a 1, which means that's your h, and you can go put 1 in for h and say, okay, now all I got to do is find k. Well, here's how we find k right here. You put the 1 into the function, which means you take the 1 and you substitute it in for every x in your equation. 3 times 1 squared. Okay, 1 squared is 1 times 3 is 3. -6 times 1 still stays -6. 3 minus 6 is -3 plus 1. That's a -2, and we can put that in for k. And there's your equation. Now, what I like to do with your calculator here, all right, is again graph this, just like we did in the previous example. Graph it, put it in for 3x, type in 3x squared minus 6x plus 1. And as it says here, when you graph it, you can enter the 1 for the x in the calculator. And what's going to be cool is that when you do that graph, you hit the trace button, x and y shows up on the bottom, you type in a 1, and then it tells you the y coordinate, which is -2. That's what we want. But here's what I really like is that your cursor is flashing at the bottom of your graph. Now, if I would have made a sign error, for example, I didn't put in two negatives, I goofed up my signs, I put in a -1, -1 would put my cursor over here, and now I know -1 is incorrect. I need to go check my signs. So this is a great way to make sure that your vertex h and k are right by using your calculator. So again, your calculator is second, or excuse me, not second, you graph it, hit the trace button, x and y shows up on the bottom of your screen, and you type in the values. All right, next example. Here we have 3x squared. Again, we identify your a, your b, and your c. So put the 3 in for your answer. Vertex formula, -8. That's going to be a +8. We can reduce the 2 and the 8 to get us 4/3. And that's what we're going to be substituting into our function. Again, this is your h, and you can go put it in for h. Holy cow, I don't think I want to put 4/3 into every x and do a bunch of fraction work. Okay, not by hand for sure. So here again, using your calculator, enter this equation into y1. You graph it, you trace it, so x and y comes on the bottom, and you type in your 4/3. Now, I want to explain, so pay close attention here. When you're at this x and you hit the 4, do not hit divide. If you hit alpha y equals, choice number 1 to get your fraction, it gives you this really thick dark fraction bar, which means when it returns the answer for y, it will be in fraction form. And I'm set up then to say, okay, hey, I just found my k, -1/3. I'll put that in to my equation, and we'll call it done. Now, I get it. You might have an old calculator like this screenshot down here that you can't do the fraction feature. You don't have alpha y equals as an option. So if you type in 4 divided by 3, notice the difference in the thickness of that bar. If it's a skinny bar, this is division, and it's going to give you a decimal. So now y has this value stored into it. So if you go back to your home screen, second mode, and type in alpha y, then the math button, choice number 1 to return your answer as a fraction, it'll give you negative 1/3, and then you can put it into your equation. So that's one way to avoid fraction work. All right, so there's your two techniques, completing the square and the vertex formula. Completing the square works great when there's a 1 in front of your x squared. If it's not a 1 like these two examples, then use this vertex formula and your calculator to help you out.